All right. Okay. Looks like we are recording now. Okay, fine. So this is in continuation to the other sessions that we did previously, and this is the part two for that, where as part of the DevOps series that we have been doing, and this is the part two for multi-region site for XP scale down AKS Kubernetes part two. We were not able to complete the demo last time because obviously we had time limitations. So in this demo, we are going to be specifically focusing on the demo side of it. Okay, that's just me, that's we, you know, us both already, right? Let's look into the architecture because that's going to be the interesting aspect here. Okay, so the architecture would look like something like this. Okay, and you have, yeah, okay, not this one, sorry. Okay, this is the one. So this is how in general the Kubernetes multi-region architecture would look like. Okay, where you're going to be having a region A and a region B. Let me try to mute. Okay. And we'll have a VNet pairing between them. This is the same architecture we discussed last time. So essentially the user will end up on the traffic manager. The traffic manager based on what, you know, priorities or parameters that we have set in the traffic manager is going to be routed to either this one or this one. But this is in general how the architecture for the Kubernetes is going to look like. I haven't listed all the pods in the backend here because otherwise the environment or the architecture would have been too cluttered. So just on a very high level, I've listed here. But this is how in general would look like with an application gateway defined at each of the region. Okay, very simple. Since this is going to be a half an hour of any session, I'm going to be stopping, not going ahead with the discussions anymore. Instead, I will jump into the next part. So I'll stop sharing the screen and you can start.
Sure. Let me share the screen. Okay, I think I'm not able to. Could you please make me the host?
Sure, give me a second. Okay,
Okay,
I made
thank
it
you.
host.
Okay, let me share the screen. So in the last session, as you know, we have discussed about how the overall cluster looks like. But today what we're going to do is I'm going to just give you a rough overview about how the cluster was being built, and then I'm going to show you the connectivity. We know that the last session Hardeep was explained about what is the architecture. So from here, from the Azure console, as you can see, we have basically have two clusters actually. So this one prod cluster, prod primary 301 cluster one, as well as prod secondary 01 secondary 301 cluster. These are two clusters basically. So one, as you can see, it is in East US, the other one is West US, and both are running on 1.19.6 Kubernetes, where 1.20.5 is the new one. Yeah. So here, what we need to understand, this is considered as primary. This is considered as primary. Let me open and show it to you what exactly is inside in both. So as you can see, if I go to the workloads, on the primary cluster, you will see a ton of pods actually. You can see like a ton of pods, a lot of pods which are basically running here. So which is running the whole Sitecore infrastructure, by the way. And we can see like if I go to the secondary, you don't find a lot of stuff because this is acting as a secondary in case if you're performing any maintenance task, or if you are performing any sort of or an unexpected downtime. The expectation is the traffic will automatically go this way. So as you can see, the CD pods are running. Only the CD pods are running here, as well as in the primary we're having the whole stuff actually here, a whole lot of pods, which is actually the production environment. And this now the load balancing is happening from the application gateway. As you can see, if I go to the application gateways, so each cluster will have an application gateway. So if I basically come here, so these are the two application gateways. I'll do one thing. I'm going to say so I have two actually. One is you can see like a prod primary 01 class. This is a primary one which is actually going to the east US, and this is a secondary one which is going to the west US, by the way. Okay, so we have these two application gateways, and let me tell you, this is not only application gateway, this works as AGC actually. That means application gateway ingress controller. This is responsible for diverting the traffic to the backend services and in turn to the pods at the backend. Okay, so to give a rough glimpse of what is going on inside, if I go to the listeners, you can see a lot of listeners, both 80 and 443, which will do the redirection as well towards 443 for all the service which you are using. So for the so for example, if you understand what are the services we are running here, so if I go back and show you the services, this is a primary cluster, and these are the services we are running, like solar, redis, cd blue, cm, cta, cube, xdv automation, everything, all the services are running. And even, and we are actually using the vnet peering to get the secondary cluster, right? The pods are actually connecting to the primary. We are using a vnet peering and getting done. Okay, so as you can see, both the clusters are up and running, and both are being load balanced by application gateway. Now on the
So
front,
one, just
yes.
one. So the solar is also running on the pods, right? Or they are VM.
Yeah, so this is right now, the solar is running on the pod right now. So it
Okay.
should be external, by the way. The
Hmm.
database is running externally, by the way, and Redis is external, but the solar is internal because you require heavy infrastructure for that one. So most probably
Right.
like three machines, right? So it's a overload,
Yeah.
overkill. So that's why.
Okay. Okay.
But the recommendation is it should be external from a Sitecore.
Right. Okay.
Now, coming to this one, so here what we're going to do is we are using as a traffic manager here. You see, like we have two clusters, one is dng and hi, but we're going to concentrate on hisi core. It means horizontal site core, by the way. And if I open this one, and I have a DNS name, and what you can notice, you have two endpoints, by the way. You can see like primary, which is the primary will goes to the east US, by the way. You can see the target is application gateway, application gateway public IP, by the way. This is actually going to the primary cluster, which is in the east US. Likewise, the second one is basically going to the west US, by the way. So, and you can see both the endpoints are up and running. So one thing what I want to do here is I want to note down the IPs, by the way. So what are the IPs we are actually using, right? To make you understand, is it really happening or not? So let's do one thing. So this is the IP of the primary. So I'm going to open a notepad to make sure whether it is happening or not. So let me tell you, I'm going to do this. I'm going to say this is east US, which is primary, by the way. Okay, and if I go to the application, and the second one is this one. So once the failover is happening and whether the traffic is not, whether it is routing or not, we're going to check it out. Okay, right. So right now, if and one thing is this, as we can see, this is hi core traffic manager.net. This is not the actual site, by the way, right? We need to have even the DNS as well. So what we do is in the DNS, I already added a record, by the way. So if we go to the DNS zones, we have our own DNS zones where I'm actually added the zone actually, which we're going to use www2 as a domain name. So the website will be www2.hi.zone. So see, this is already updated, by the way. So, and the important thing is this is back actually routing towards the Azure resource site core, which is nothing but, as you can see, it is basically the traffic manager. That means somebody access or anybody access www2.hi.zone, the traffic will be routed to the traffic manager hi site core, basically this URL. And we know that traffic manager really not doing any load balancing. It is actually selecting the best candidate to route based upon the routing protocol we use. Right now we are using priority, by the way. So obviously when you actually access this URL, the traffic manager is going to find which one is primary and directly send the host name, because we have configured our host headers to contact this one, which is a backend service, by the way. Okay, that means let me open this, and I'm going to www2.hi.zone, which is actually reaching out to this one. So what makes me to think that it is going to the primary one? Okay, let's open this one. So I'm going to refresh, and if I go to get, and if I open this one, and I'm actually reaching out to the IP, something like this actually. What's this IP? And the IP is if you can see, it is actually routing to the east US, by the way. So that means, yes, as expected, the traffic manager routing table, this is basically priority. Now we can simulate a downtime by taking the entire thing down. And one thing is, you need to understand the TTL is 60, so we need to take at least 60 seconds. It will take 60 seconds at least to route the traffic to the secondary. So I'm going to simulate a failure. The simulatory failure, I'm going to disable this endpoint. Of course, we can delete the endpoint also, but we can also disable that one, right? So what I'm going to do is, I'm going to disable this endpoint and save it. Okay, so the expectation is, since this is disabled, and after 60 seconds, when I try to access using an incognito mode of any browser and try to reach it out, you should be able to reach out the secondary, and we should have a functional website. That means it is actually reaching to the secondary cluster. This is a primary cluster, this is a secondary cluster, and basically it will be hitting the service here, the CD blue service, which is actually in the secondary site, that is in the West US, by the way. So what I can do is, so I'm going to leave like that. I'm going to leave this. I'm going to open a new window, by the way. So if I'm going to keep it, paste it, and try to access this one. So I'm getting this one, but I want to make sure. I'm going to basically go press F2. I'm going to refresh, select this. If I go here, and you can see it is changed, guys. As you can see, it is actually going to the secondary one. See, I'm going to copy this. If I go back, you see that? So it is actually going to the secondary. So this is how basically, even in an event of catastrophic failure or some sort of a issue, like anything happened, because nowadays we can see like the cloud is going up and down recently, some multiple failures. So what will happen is, the decision will be made by the traffic manager, and automatically the traffic will be routed to the secondary priority. So like this, we can have multiple, it's not like one. We can have basically like multiple secondaries and check it out. So, but in the meanwhile, if I go back, imagine it comes up, by the way. So the primary comes up again. So obviously the primary has the priority of 1. So we need to wait for some time and check it out. So automatically the traffic after 1 minute should be sending to the primary, by the way. So I'll do one thing. Let me close this. Let's wait for a minute. So and then what will happen is, we're going to check it again. All the traffic will go to the secondary. Now the whole deployment here, the whole deployment is basically performed using the pipelines, by the way. So if I go here, go to our releases, and this is our primary the primary east US site, which where we have like last time I showed you, but we have an opportunity to show you where it is going to do stage by stage automated deployment for 14 stages, and even it is going to enable the web application firewall in a prevention mode, by the way. Yeah, and it is purely option for the customer. If they want to have the DR, they can go, or they can have actually only have one site, right? They can do that one. So this will be the second. This one is the primary, and this one is the secondary. Probably less number of stages when compared to the primary. You can see 1, 2, 3. So it's less number of stages. You don't have like 14 stages, and it is planned to deploy less number of pods. But what will happen is, so both the East US and West US will be connected using the VNet peering, and they work as one team. And if the primary goes down, the secondary will take over. And we have a little complex complex kind of connectivity between, which we'll understand later point. So let's check it out whether it is up or running. So I'm going to go here, and I'm going to paste the www.hi.zone. Let's verify the traffic is reverted or not. I'll go network. I'm going to refresh, check this. As you can see, address is basically resolving to the primary. This is how, as you can see, this is actually sent back to the East US, by the way. This is how basically the failover will happen, folks. Okay, so let me go back. And as you see, everything is coming from the Azure DevOps, and this is the repository which was been integrated, by the way, along with the pipeline. So in future still we are actually testing different options which will be integrated in future as well, like front door as well as firewall, which still yet to be tested. In future we will include that one as well for additional layer of security. Any questions, folks?
All good.
Yeah.
Really, yeah, straightforward. So yeah, all good.
Hardeep, can I answer?
Yeah. Yeah, so we're good for now. Like I said, this was going to be a quick one. So we have a question from Vinod, and he's saying, so the traffic manager will work like a replica set. Um,
No, it's not actually. So what traffic manager will basically load balancing between regions. It's not replica set. So replica set is different. It's a Kubernetes component, where this one is literally doing a load balancing between two different clusters. So you have like two clusters, right? Literally, these are physical two clusters in different regions, and load balancer is traffic manager, works on DNS level.
Okay, thank you.
all right, awesome. So as again, this was going to be a quick demo. We did not have the opportunity last time. Um, if anyone has any questions, please ask. Otherwise, good for now. And with this, we will probably stop the cloud engineering sessions, and we'll start focusing on the validity side of it in the next sessions that we are planning. So thank you all for your time. I appreciate it. And thank you very much. Thank you, Sri.
Yeah. Bye for now, guys.
Bye. Thank you.